Welcome to the multivariable calculus section. My name is Joshua Shongway, and I will be introducing the first topic of Calculus 3, the dot product. Now, the dot product, or the scalar product, takes two equal length vectors and returns a single number. Let's use the two vectors a and b. Now, when we write out the two vectors, we get a dot b. And when we expand this, we get a1, a2, a3 dot b1, b2, b3. Now, there is a method to the madness. The reason why there are three components per said vector is because when we write out the full vector form, we get something that looks like this. A is equal to AI plus B. Oh man, it's not a B. It's an AJ plus AK. And for our B vector, we get BI plus BJ plus BK. Now, some of you are asking yourselves, what is an I, a J, and a K? Well, when we look at our three-dimensional graph in space where we have our two vectors A and B, we know that along the x-axis we have an I component, along the y-axis we have a J component, and along the z-axis we have a K component. So, in essence, our A vector is made up of an AI, an AJ, and an AK, and our B vector is made up of a BI, a BJ, and a BK. Now, when we find the dot product or the scalar product of our two vectors, we get something that looks like this. This is our scalar product. And now the reason why that is true is because the true definition of a dot product is that the magnitude, let me change color. The magnitude of A times the magnitude of B times cosine theta, and our theta lies in between the two vectors, is equal to our scalar product. Now, all that says is that the length of the vector A times the length of the vector B scaled by the cosine of theta is equal to the scalar product of the two vectors. And now that actually makes sense because when we look at our actual equation for the dot product, we get something that looks like A1, B1 plus A2, B2 plus A3, B3. Now what that says is that the I components multiplied together plus the J components multiplied together plus the K components multiplied together will give us the scalar product, or a singular number, of the two vectors. So now let's try a problem. We have the vector A, 1, 2, 3, and the vector B, 3, 4, 5. We want to find the dot product between the two vectors. So A dot B is equal to A1, B1 plus A2, B2 plus A3, B3. We know that. And now we want to find our A1s, or B1s, or all of that good stuff. So A1 is equal to 1, A2 is equal to 2, A3 is equal to 3. Now isn't that nice? And B1 is equal to 3, B2 is equal to 4, and B3 is equal to 5. So when we write out our full equation, we get something that looks like this. 1 times 3 plus 2 times 4 plus 3 times 5. Now 1 times 3 is equal to 3, and 2 times 4 is equal to 8, and 3 times 5 is equal to 15. We get 18 plus 8 is equal to 26, and that is our dot product of the vectors. Now if you need more practice problems or help, we have 3 other learning types, and I suggest those. Thank you.